Okay, lads, let's try and get through a few of these questions. So, the amount of substance remaining in a solution reduces exponentially over time. The experiment measured the percentage of a substance remaining in the solution. The percentage is measured same time each day. The data is collected over the first 4 days in the table below. Based on the data in the table, estimate which is the first day on which the percentage of the substance of solution will be less than 0.01. Okay. So what we're going to do is we're going to try and find out an R value here, okay? We're trying to see what's going on. So when we divide, it looks like a geometric sequence similar to exponential. So the R value could be T2 divided by T1, which ends up to be 42.75 divided by 95. What we get there is an R value of 9/20, or 0.45. Okay, so that's pretty good. All right. Now we're also going to check out is it the same as T2, T3 over T2? Let's see if it's the same value for that. So let's get this number here. We go 42.75. Or say T3 over T3 over 2.75. And we see it's also 0.45, right? So very much R equals 0.45. Okay, now we go for Tn over a geometric sequence. So Tn equals R ARn to the minus 1. A is 95, so it's going to be 95 by 0.45 to the power of n minus 1. Okay, now we put that into the calculator, the table function, mode table function, and we have 95.45 to the power of x minus 1. And what we start at 1 and at, I don't know, 10, step of 1. We see all these numbers here. Now, less than 0.01. So looking for something less than 0.01. Now let's go a bit higher than that. Start at 1 and at 20. Go down. There we are there. Day 13 is what we're looking at here, I reckon. So the 12th or 13th day. Okay. So sometimes substance solution less than self summary between day 12 to 13. Okay, so here's what we're going to do. So it's going to be Tn has to be less than 0.01, which means that this is less than 0.01. Divide both sides by 95, so 0.45 n minus 1 less than 0.01 over 95. It's in the power position. So because that's in the power position, we're going to have to log both sides, okay? So we go log base 10, any log, to be honest. Any log whatsoever, so we'll just do 0.01 over 0.95. We can do ln if you wanted. Same answer will result, okay? So 0.01 over 95. Okay. So what we're then going to get here is use the power rule of indices. So we get n power rule of log, that is. So it's going to be n minus 1 to the front. Log base 10.45 less than log base 10.01 over 95. Okay, and that's a curly bracket, like so. Next thing after this is we're going to say is n minus 1. Well, we're going to figure out what this is in the calculator. Okay, so log 0.45. Log 0.45 actually turns out to be negative, okay? So log 0.45 minus 0.348 So point minus 0.3468 and minus 1 minus 0.3468 less than, and we do this one here as well, log 0.01 divided by 95. Let's see if this one's negative as well. Minus 0.3978. So minus. Okay. So multiply both sides by minus. If I multiply both sides by minus 1, what can happen here is I'm going to multiply both sides by minus 1. So we get is n minus 1 times 0.3468 greater than 3468 greater than 0.3978. Then what we get here is n minus 1 greater than 3.978 divided by 0.3468. So 0.3978, 3.978 divided by 0.3468. What we get here is 11.47. Okay, so n minus 1 greater than 11.47. So equals n greater than 12.47. That minus 1 moves over to the other side. And what we have here then is estimate, based on data, estimate which is the first day. So it would be day 12, halfway through day 12. So day 12 before day 13. Okay. Okie dokes. Moving on to the next question. Okay. The square has a length of 2 centimeters. Okay. And the midpoints of the side squares are joined to form another square. The process continues. The first 3 squares in the process is shown. Find the sum of the perimeters of the squares in this process continued indefinitely. Keep your answer in the form A plus B root C. Okay. So let's start off with A. So this is 2. This is 2, 2, and 2. What we're going to do next is we're just going to cut it through the middle, like so, or maybe even less. We find the center point of the square, and then we cut it like so, through to the middle and downwards. Okay, so what we effectively have is a triangle with 2 here. So 2, 2, x. X squared equals 2 squared plus 2 squared. X squared equals root 8. X equals 2 root 2. Okay, so that's stage 2. So we get rid of this one here, this one here, this one here. So we have is 2, 2, 2, 2, 2. And then we have the red side, which is 2 root 2, 2 root 2, 2 root 2. Now, I'm going to look at next is probably this side here. Okay, so I'm just going to highlight what I'm going to go after next. I'm going to go after this side here, this triangle here. Okay, so I'm going to go after this triangle here. What we're going to have is they're the same length, so we're going to call that let's call that B. This here B. Alright, and we call this root 2. So it's going to be B squared plus B squared equals root 2 squared. 2B squared equals 2. And that right, root 2 squared of 2 root 2. Yeah. Wait. So my bad. B squared plus B squared equals 2 root 2 squared. 2 root 2 squared is going to be 8. 2b squared. B squared equals 4b equals 2. So this one here is going to be, that's going to be 4. Okay? So what we have here is the following. We have the several perimeters, okay? So the first perimeter is going to be perimeter of the small square is going to be a perimeter of 8. The perimeter of the second square, which is all the 2 root 2's, P1, P2 is going to be 8 root 2, and then P3, which is going to be just simply, that's 2, so that's 2, so it's going to be 4 by 4 by 4 by 4, which is 16. Okay, and now we're going to raise this up. And what we're going to be left with is a bit like this. Right? So P1 is 8, P2 is 8 root 2, P3 is 16. So it's geometric. So the same thing as T1, T2, T3 indefinitely plus dot 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 T infinity. Our A value is 8. Our R value is T2 divided by T1, which is 8 root 2 over 8, which is root 2. Or R equals T3 over T2, which is 16 over 8 root 2, which once again should equal root 2. Or in the calculator, root 2 is 1.414. 16 divided by 8 root 2, you'll see is exactly the same thing, 1.41, same stuff. Right? So we need S infinity, which is T1 plus T2 plus dot 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 all of T infinity. S infinity, therefore, is A bracket 1 minus R. So what we're going to get here is 8 divided by 1 minus root 2. So 8 by 1 minus root 2 minus 8 minus 8 root 2. What? A into 1 minus R. Stop. Alright.